Welcome to the audiobook of Conjectures and Refutations by Karl Popper, narrated by Elyse Hargreaves with the consent of the University of Klagenfurt, Karl Popper Library. Chapter 11. The Demarcation between Science and Metaphysics. I think, Socrates, as presumably you do yourself, that in this life it is either altogether beyond our powers, or at least very difficult, to attain certain knowledge about matters such as these. And yet a man would be a coward if he did not try with all his might to refute every argument about them, refusing to give up before he has worn himself out by examining them from all sides. For he must do one of two things. Either he must learn or discover the truth about these matters, or, if that is beyond his powers, he must grasp whatever human theory seems to him to be the best, and to offer the hardest resistance to refutation. And, mounting on it as upon a raft, he must venture into danger and sail upon it through life, unless he can mount on something stronger, less dangerous, and more trustworthy. Plato. Summary. Put in a nutshell, my thesis amounts to this. The repeated attempts made by Rudolf Carnap to show that the demarcation between science and metaphysics coincides with that between sense and nonsense have failed. The reason is that the positivistic concept of meaning or sense, or of verifiability or of inductive confirmability, etc., is inappropriate for achieving this demarcation, simply because metaphysics need not be meaningless even though it is not science. In all its variants, demarcation by meaninglessness has tended to be, at the same time, too narrow and too wide. As against all intentions and all claims, it has tended to exclude scientific theories as meaningless, while failing to exclude even that part of metaphysics which is known as rational theology. 1. Introduction. Writing about Carnap, and in criticism of Carnap, brings back to my mind the time when I first met him, at a seminar in 1928 or 1929. It brings back even more vividly a later occasion, in 1932, in the beautiful Tyrolese hills, when I had the opportunity of spending part of my holidays in prolonged critical discussions with Carnap and with Herbert Feigl, in the company of our wives. We had a happy time, with plenty of sunshine, and I think that we all tremendously enjoyed these long and fascinating talks, interspersed with a little climbing, but never interrupted by it. None of us will ever forget, I am sure, how Carnap once led us in a steep climb up a treckless hill, through a beautiful and almost impenetrable thicket of alpine rhododendrons, and how he led us, at the same time, through a beautiful and almost impenetrable thicket of arguments, whose topic induced Feigl to christen our hill Semantisch Schnuppy, something like semantical shooting star. Though several years had to elapse before Carnap, stimulated by Tarski's criticism, discovered the track which led him from logical syntax to semantics. I found in Carnap not only one of the most captivating persons I had ever met, but also a thinker utterly absorbed in and devoted to his problems, and eager to listen to criticism. And indeed, among some other characteristics which Carnap shares with Bertrand Russell, whose influence upon Carnap and upon us all was greater than anyone else's, is his intellectual courage in changing his mind, under the influence of criticism, even on points of fundamental importance to his philosophy. I had come to Tyrol with the manuscript of a large book, entitled The Two Fundamental Problems of Epistemology. It is still unpublished, but an English translation may appear one day. Parts of it were later incorporated in a much abbreviated form in my Logic of Scientific Discovery. The two problems were the problems of induction and of demarcation, the demarcation between science and metaphysics. The book contained, among much else, a fairly detailed criticism of Wittgenstein's and Carnap's doctrine of the elimination or overthrow of metaphysics through meaning analysis. I criticized this doctrine not from a metaphysical point of view, but from the point of view of one who, interested in science, feared that this doctrine, far from defeating the supposed enemy metaphysics, in effect presented the enemy with the keys of the beleaguered city. My criticism was directed, largely, against two books of Carnap's, Afbau for short, and Sein Probleme in der Philosophie, and some of his articles in Erkenntnis. Carnap accepted part of it, although he felt, as it turned out, that I had exaggerated the differences between my views and those of the Vienna Circle, of which he was a leading member. This silenced me for many years, especially as Carnap paid so much attention to my criticism in his Testability and Meaning. But I felt all the time that the differences between our views were far from being imaginary, and my feeling that they were important was much enhanced by Carnap's most recent papers and books on probability and induction. The purpose of this paper is to discuss these differences, so far as they concern the problem of demarcation. It is with reluctance that I expose myself again to the charge of exaggerating differences, but I hope that Professor Carnap won't be prevented from speaking his mind by an apprehension of silencing me for the rest of my days. I promise to be more reasonable this time. I have, however, accepted the invitation to write this paper, and this leaves me no alternative but to try to characterize our differences as clearly and as sharply as possible. In other words, I must try to defend the theses that these differences are real as I have felt them to be for the last 25 years. In section 2 of this paper, I try to give a brief outline of some of my own views which form the basis of my criticism. In the later sections, I try to trace the development, as I see it, of Carnap's views on the problem of the demarcation between science and metaphysics. My approach throughout is critical rather than historical, but I have aimed at historical accuracy, if not at historical completeness. 2. My own view of the problem. It was in 1919 that I first faced the problem of drawing a line of demarcation between those statements and systems of statements which could be properly described as belonging to empirical science, and others which might, perhaps, be described as pseudoscientific, or, in certain contexts, as metaphysical, or which belonged, perhaps, to pure logic or to pure mathematics. This is a problem which has agitated many philosophers since the time of Bacon, although I have never found an explicit formulation of it. The most widely accepted view was that science was characterized by its observational basis, or by its inductive method, while pseudosciences and metaphysics were characterized by their speculative method, or, as Bacon said, by the fact that they operated with mental anticipations, something very similar to hypotheses. This view I have never been able to accept. The modern theories of physics, especially Einstein's theory, widely discussed in the year 1919, were highly speculative and abstract, and very far removed from what might be called their observational basis. All attempts to show that they were more or less directly based on observations were unconvincing. The same was true even of Newton's theory. Bacon had raised objections against the Copernican system on the grounds that it needlessly did violence to our senses. And, in general, the best physical theories always resembled what Bacon had dismissed as mental anticipations. On the other hand, many superstitious beliefs and many rule-of-thumb procedures for planting, etc., to be found in popular almanacs and dream books, have had much more to do with observations, and have, no doubt, often been based on something like induction. Astrologers, more especially, have always claimed that their science was based upon a great wealth of inductive material. This claim is, perhaps, unfounded, but I have never heard of any attempt to discredit astrology by a critical investigation of its alleged inductive material. Nevertheless, astrology was rejected by modern science because it did not fit accepted theories and methods. Thus, there clearly was a need for a different criterion of demarcation, and I proposed, though years elapsed before I published this proposal, that the refutability or falsifiability of a theoretical system should be taken as the criterion of demarcation. According to this view, which I still uphold, a system is to be considered as scientific only if it makes assertions which may clash with observations, and a system is, in fact, tested by attempts to produce such clashes, that is to say, by attempts to refute it. Thus, testability is the same as refutability, and can therefore likewise be taken as a criterion of demarcation. This is a view of science which takes its critical approach to be its most important characteristic. Thus, a scientist should look upon a theory from the point of view of whether it can be critically discussed, whether it exposes itself to criticism of all kinds, and, if it does, whether it is able to stand up to it. Newton's theory, for example, predicted deviations from Kepler's laws due to the interactions of the planets, which had not been observed at the time. It exposed itself thereby to attempted empirical refutations, whose failure meant the success of the theory. Einstein's theory was tested in a similar way, and indeed, all real tests are attempted refutations. Only if a theory successfully withstands the pressure of these attempted refutations can we claim that it is confirmed or corroborated by experience. There are, moreover, as I found later, degrees of testability. Some theories expose themselves to possible refutations more boldly than others. For example, a theory from which we can deduce precise numerical predictions about the splitting up of the spectral lines of light emitted by atoms in magnetic fields of varying strength will be more exposed to experimental refutation than one which merely predicts that a magnetic field influences the emission of light. A theory which is more precise and more easily refutable than another will also be the more interesting one. Since it is the more daring one, it will be the one which is less probable. But it is better testable, for we can make our tests more precise and more severe. And if it stands up to severe tests, it will be better confirmed, or better attested, by these tests. Thus, confirmability, or attestability, or corroborability, must increase with testability. This indicates that the criterion of demarcation cannot be an absolutely sharp one, but will itself have degrees. There will be well-testable theories, hardly testable theories, and non-testable theories. Those which are non-testable are of no interest to empirical scientists. They may be described as metaphysical. Here I must again stress a point which has often been misunderstood. Perhaps I can avoid these misunderstandings if I put my point now in this way. Take a square to represent the class of all statements of a language in which we intend to formulate a science. Draw a broad horizontal line dividing it into an upper and lower half. Write science and testable into the upper half, and metaphysics and non-testable into the lower. Then I hope you will realize that I do not propose to draw the line of demarcation in such a way that it coincides with the limits of a language, leaving science inside, and banning metaphysics by excluding it from the class of meaningful statements. On the contrary, beginning with my first publication on this subject, I stressed the fact that it would be inadequate to draw the line of demarcation between science and metaphysics so as to exclude metaphysics as nonsensical from a meaningful language. I have indicated one of the reasons for this by saying that we must not try to draw the line too sharply. This becomes clear if we remember that most of our scientific theories originate in myths. The Copernican system, for example, was inspired by a Neoplatonic worship of the light of the sun, who had to occupy the center because of his nobility. This indicates how myths may develop testable components. They may, in the course of discussion, become fruitful and important for science. In my logic of scientific discovery, I gave several examples of myths which have become most important for science, among them atomism and the corpuscular theory of light. It would hardly contribute to clarity if we were to say that these theories are nonsensical gibberish in one stage of their development and then suddenly become good sense in another. Another argument is the following. It may happen, and it turns out to be an important case, that a certain statement belongs to science since it is testable, while its negation turns out not to be testable, so that it must be placed below the line of demarcation. This is indeed the case with the most important and most severely testable statements, the universal laws of science. I recommend, in my logic of scientific discovery, that they should be expressed, for certain purposes, in a form like, there does not exist any perpetual motion machine. This is sometimes called Planck's formulation of the first law of thermodynamics. That is to say, in the form of a negation of an existential statement. The corresponding existential statement, there exists a perpetual motion machine, would belong, I suggest, together with there exists a sea serpent, to those below the line of demarcation, as opposed to there is a sea serpent now on view in the British Museum, which is well above the line since it can easily be tested. But we do not know how to test an isolated purely existential assertion. I cannot, in this place, argue for the adequacy of the view that isolated purely existential statements should be classed as untestable and as falling outside the scientist's range of interest. I only wish to make clear that if this view is accepted, then it would be strange to call metaphysical statements meaningless or to exclude them from our language. For if we accept the negation of an existential statement as meaningful, then we must accept the existential statement itself also as meaningful. I have been forced to stress this point because my position has repeatedly been described as a proposal to take falsifiability or refutability as a criterion of meaning rather than of demarcation, or as a proposal to exclude existential statements from our language, or perhaps from the language of science. Even Carnap, who discusses my position in considerable detail and reports it correctly, feels himself compelled to interpret it as a proposal to exclude metaphysical statements from some language or other. But it is a fact that, beginning with my first publication on this subject, I always dismissed the problem of meaninglessness as a pseudo-problem, and I was always opposed to the idea that it may be identified with the problem of demarcation. This is my view still. 3. Carnap's first theory of meaninglessness. One of the theories which I had criticized in my manuscript, and later, more briefly, in my logic of scientific discovery, was the assertion that metaphysics was meaningless and consisted of nonsensical pseudo-propositions. This theory was supposed to bring about the overthrow of metaphysics and to destroy it more radically and more effectively than any earlier anti-metaphysical philosophy. But as I pointed out in my criticism, the theory was based on a naive and naturalistic view of the problem of meaningfulness, Moreover, its propagators, in their anxiety to oust metaphysics, failed to notice that they were throwing all scientific theories on the same scrap heap as the meaningless metaphysical theories. All this, I suggested, was a consequence of trying to destroy metaphysics instead of looking for a criterion of demarcation. The naturalistic theory, as I called it, of meaningfulness and meaninglessness is Carnap's Aufbau, which here followed Wittgenstein's Tractatus, was abandoned by Carnap long ago. It has been replaced by the more sophisticated doctrine that a given expression is a meaningful sentence in a certain artificial language if, and only if, it complies with the rules of formation for well-formed formulae or sentences in that language. In my opinion, the development from the naive or naturalistic theory to the more sophisticated doctrine was a highly important and desirable one. But its full significance has not been appreciated, as far as I can see. Apparently, it has not been noticed that it simply destroys the doctrine of the meaninglessness of metaphysics. It is for this reason that I am now going to discuss this development in some detail. By the naturalistic theory of meaninglessness, I mean the doctrine that every linguistic expression purporting to be an assertion is either meaningful or meaningless, not by convention or as a result of the rules which have been laid down by convention, but as a matter of actual fact, or due to its nature, just as a plant is, or is not, green in fact, or by nature, and not by conventional rules. According to Wittgenstein's famous verifiability criterion of meaning, which Carnap accepted, a sentence-like expression, or a string of words, was a meaningful sentence or proposition if, and only if, it satisfied the conditions A and B, or a condition C, which will be stated later. A. All words which occurred in it had meaning, and B. All words which occurred in it fitted together properly. According to condition A of the theory, which goes back to Hobbes and Berkeley, a string of words was meaningless if any word in it was meaningless. Wittgenstein formulated it in his Tractatus. The right method of philosophy is this: when someone wished to say something metaphysical, to demonstrate to him that he had given no meaning to certain signs in his propositions. According to Hobbes and Berkeley, the only way in which a meaning was given to a word was by linking, associating, the word with certain observable experiences or phenomena. Wittgenstein himself was not explicit on this point, but Carnap was. In his Aufbau, he tried to show that all concepts used in the sciences could be defined on the basis of, my own, observational or perceptual experience. He called such a definition of a concept its constitution, and the resulting system of concepts a constitution system. And he asserted that metaphysical concepts could not be constituted. Condition B of the theory goes back to Bertrand Russell, who suggested that certain combinations of symbols, which looked like propositions, must be absolutely meaningless, not simply false, if certain paradoxes were to be avoided. Russell did not mean to make a proposal that we should consider these combinations as contrary to some partially conventional rules for forming sentences in order to avoid the paradoxes. Rather, he thought he had discovered the fact that these apparently meaningful formulae expressed nothing, and that they were, in nature or in essence, meaningless pseudo-propositions. A formula like A is an element of A, or A is not an element of A, looked like a proposition because it contained two subjects and a two-termed predicate, but it was not a genuine proposition or sentence because a formula of the form X is an element of Y could be a proposition only if X was one type level lower than y, a condition which obviously could not be satisfied if the symbol a was to be substituted for both x and y. This showed that a disregard of the type level of words, or of entities designated by them, could make sentence-like expressions meaningless, and according to Wittgenstein's Tractatus, and more explicitly, Carnap's Aufbau, this confusion was a major source of metaphysical nonsense, that is, of the offering of pseudo-propositions for propositions. It was called confusion of spheres in the Aufbau. It is the same kind of confusion which nowadays is often called a category mistake. According to the Aufbau, for example, my own experiences, physical bodies, and the experiences of others all belong to different spheres or types or categories, and a confusion of these must lead to pseudo-propositions and to pseudo-problems. Carnap describes the difference between physical and psychological entities as one between two types of order, subsisting within one kind or range of ultimate entities, which leads him to a solution of the body-mind problem on the lines of neutral monism. The outline just given of the naive or naturalistic theory of meaningful and meaningless linguistic expressions covers only one side of this theory. There is another side to it, the so-called verifiability criterion, which may be formulated as the condition C. C. An alleged proposition or sentence is genuine if and only if it is a truth function of or reducible to elementary or atomic propositions expressing observations or perceptions. In other words, it is meaningful if and only if it is so related to some observation sentences that its truth follows from the truth of these observation sentences. It is certain, Carnap writes, that a string of words has meaning only if its derivability relations from protocol sentences, observation sentences, are given. That is to say, if the way to its verification is known. The conditions A and B on the one hand, and C on the other hand, were asserted by Carnap to be equivalent. A result of this theory was, in Carnap's words, that the alleged sentences of metaphysics stand revealed by logical analysis as pseudo-sentences. Carnap's theory of the intrinsic meaningfulness or meaninglessness of strings of words was soon to be modified, but in order to prepare a basis for judging these modifications, I must say a few words of criticism here. First, a word on C, the verifiability criterion of meaning. This criterion excludes from the realm of meaning all scientific theories or laws of nature, for these are no more reducible to observation reports than so-called metaphysical pseudo-propositions. Thus, the criterion of meaning leads to the wrong demarcation of science and metaphysics. This criticism was accepted by Carnap in his logical syntax of language and in his testability and meaning. But even his latest theories are still open to it, as I shall try to show in section 6 below. Next, we consider condition A of the doctrine, the nominalistic view that only empirical definable words or signs have meaning. Here the situation is even worse, although it is very interesting. For the sake of simplicity, I begin my criticism with a very simple form of nominalism. It is the doctrine that all non-logical, or as I prefer to say, non-formative words are names, either such as Fido, of a single physical object, or as dog, shared by several such objects. Thus, dog may be the name shared by the objects Fido, Candy, and Tiffin, and so with all other words. This view may be said to interpret the various words extensionally or enumeratively. Their meaning is given by a list or an enumeration of the things they name. This thing here and that thing over there. We may call such an enumeration an enumerative definition of the meaning of a name, and a language in which all non-logical or non-formative words are supposed to be enumeratively defined may be called an enumerative language, or a purely nominalistic language. Now, we can easily show that such a purely nominalistic language is completely inadequate for any scientific purpose. This may be expressed by saying that all its sentences are analytic, either analytically true or contradictory, and that no synthetic sentences can be expressed in it. Or, if we prefer a formulation which avoids the terms analytic and synthetic, which at present are under heavy fire from Professor Quinn's guns, then we can put it in this way. In a purely nominalistic language, no sentence can be formulated whose truth or falsity could not be decided by merely comparing the defining lists or enumerations of the things which are mentioned in the sentence. Thus, the truth or falsity of any sentence is decided as soon as the words which occur in it have been given their meaning. That this is so may be seen from our example. Fido is a dog is true because Fido was one of the things enumerated by us in defining dog. As opposed to this, Chunky is a dog must be false, simply because Chunky was not one of the things to which we pointed when drawing up our list defining dog. Similarly, if I give the meaning of white by listing 1. the paper on which I am now writing, 2. my handkerchief, 3. the cloud over there, and 4. our snowman, then the statement, I have white hair, will be false, whatever the colour of my hair may be. It is clear that in such a language, hypotheses cannot be formulated. It cannot be a language of science. And conversely, every language adequate for science must contain words whose meaning is not given in an enumerative way. Or, as we may say, every scientific language must make use of genuine universals, that is, of words, whether defined or undefined, with an indeterminate extension, though perhaps with a reasonably definite intentional meaning. For the intentional analysis of meaning, see Carnap's excellent book, Meaning and Necessity. Precisely the same criticism applies to more complicated languages, especially to languages which introduce their concepts by the method of extensional abstraction, used first by Frege and Russell, provided the class of the fundamental elements upon which this method is based, and the fundamental relations between these elements, are supposed to be given extensionally by lists. Now this was the case in Carnap's Aufbau. He operated with one primitive relation, experience of remembering, which was assumed to be given in the form of a list of pairs. All concepts belonging to his constitution system were supposed to be extensionally definable on the basis of this primitive relation, that is, of the list of pairs which gave a meaning to this relation. Accordingly, all statements which could be expressed in his language were true or false, simply according to the extensional meaning of the words which occurred in them. They were all either analytically true or contradictory, owing to the absence of genuine universal words. To conclude this section, I turn to the condition B of the theory and to the doctrine of meaninglessness due to type mistakes or category mistakes. This doctrine was derived, as we have seen, from Russell's theory that an expression like A is an element of the class A must be meaningless, absolutely or intrinsically or essentially, as it were. Now, this doctrine has long since turned out to be mistaken. Admittedly, it is true that we can, with Russell, construct a language embodying a theory of types in which the expression in question is not a well-formed formula, But we can also, with Zermelo and his successors, Frenkel, Bateman, von Neumann, Bernays, Lesniewski, Quinn, Ackermann, construct languages in which the expression in question is well formed and thus meaningful, and in some of them it is even a true statement for certain values of A. These are, of course, well-known facts, but they completely destroy the idea of an inherently or naturally or essentially meaningless expression. For the expression A is an element of the class A turns out to be meaningless in one language, but meaningful in another. And this establishes that a proof that an expression is meaningless in some languages must not be mistaken for a proof of intrinsic meaninglessness. In order to prove intrinsic meaninglessness, we should have to prove a great deal. We should have to prove not merely that an alleged statement asserted or submitted by some writer or speaker is meaningless in all consistent languages, but also that there cannot exist a meaningful sentence in any consistent language which would be recognized by the writer or speaker in question as an alternative formulation of what he intended to say. And nobody has ever suggested how such a proof could possibly be given. It is important to realize that a proof of intrinsic meaninglessness would have to be valid with respect to every consistent language, and not merely with respect to every language that suffices for empirical science. Few metaphysicians assert that metaphysical statements belong to the field of the empirical sciences, and nobody would give up metaphysics because he is told that its statements cannot be formulated within these sciences, or within some language suitable for these sciences. After all, Wittgenstein's and Carnap's original theses was that metaphysics is absolutely meaningless, that it is sheer gibberish and nothing else, that it is, perhaps, of the character of sighs or groans or tears, or of surrealist poetry, but not of articulate speech. In order to show this, it would be quite insufficient to produce a proof to the effect that it cannot be expressed in languages which suffice for the needs of science. But even this insufficient proof has never been produced by anybody, in spite of the many attempts to construct metaphysics-free languages for science. Some of these attempts will be discussed in the next two sections. 4. Carnap and the language of science. Carnap's original overthrow of metaphysics was unsuccessful. The naturalistic theory of meaninglessness turned out to be baseless, and the total result was a doctrine which was just as destructive of science as it was of metaphysics. In my opinion, this was merely the consequence of an ill-advised attempt to destroy metaphysics wholesale, instead of trying to eliminate, piecemeal as it were, metaphysical elements from the various sciences, whenever we can do this without endangering scientific progress by misplaced criticism, such as had been directed by Bacon against Copernicus, or by Duhem and Mach against atomism. But the naturalistic theory of meaning was abandoned by Carnap a long time ago, as I have said. It has been replaced by the theory that whether a linguistic expression is well formed or not depends on the rules of the language to which the expression is supposed to belong, together with the theory that the rules of language are often not precise enough to decide the issue, so that we have to introduce more precise rules, and with them, an artificial language system. I wish to repeat that I regard this as a very important development, and as one that provides the key to a considerable number of interesting problems. But it leaves the problem of demarcation between science and metaphysics exactly where it was. This is my thesis. To put it quite differently, the naive or naturalistic or essentialistic theory of meaningfulness discussed in the previous section is mistaken, and had to be replaced by a theory of well-formed formulae, and with it, of languages which are artificial in being subject to definite rules. This important task has since been carried out by Carnap with great success. But this reformation of the concept of meaningfulness completely destroys the doctrine of the meaninglessness of metaphysics. And it leaves us without a hope of ever reconstructing this doctrine on the basis of the formed concept of meaninglessness. Unfortunately, this seems to have been overlooked. For Carnap and his circle, Narrated was especially influential, tried to solve the problem by constructing a language of science, a language in which every legitimate statement of science would be a well-formed formula, while none of the metaphysical theories would be expressible in it, either because the terminology was not available or because there was no well-formed formula to express it. I consider the task of constructing artificial model languages for a language of science an interesting one, but I shall try to show that the attempt to combine this task with that of destroying metaphysics by rendering it meaningless has repeatedly led to disaster. The anti-metaphysical bias is a kind of philosophical or metaphysical prejudice which prevented the system builders from carrying out their work properly. I shall try to show this briefly in this section for A, the physicalistic language, B, the language of unified science, C, the languages of logical syntax, and later in section 5, more fully for those proposed in Testability and Meaning. A, the physicalistic language. Carnap's Aufbau had sponsored what he called a methodological solipsism, taking one's own experiences as the basis upon which the concepts of science, and thus the language of science, have to be constructed. By 1931, Carnap had given this up under Narrath's influence and had adopted the theses of physicalism, according to which there was one unified language which spoke about physical things and their movements in space and time. Everything was to be expressible in this language, or translatable into it, especially psychology insofar as it was scientific. Psychology was to become radically behavioristic. Every meaningful statement of psychology, whether human or animal, was to be translatable into a statement about the spatio-temporal movements of physical bodies. The tendency underlining this program is clear. A statement about the human soul was to become as meaningless as a statement about God. Now, it may be fair enough to put statements about the soul and about God on the same level, but it seems quite questionable whether anti-metaphysical and anti-theological tendencies were much furthered by placing all our subjective experiences, or rather all statements about them, on the same level of meaninglessness as the statements of metaphysics. Theologians or metaphysicians might be very pleased to learn that statements such as God exists or the soul exists are on precisely the same level as I have conscious experiences, or there exist feelings such as love or hate distinguishable from the bodily movements which often, though not always, occupy them. There is no need, therefore, to go into the merits or demerits of the behaviorist philosophy or the translatability theses, which, in my opinion, is nothing but materialist metaphysics in linguistic trappings, and I, for one, prefer to meet it without trappings. We see that as an attempt to kill metaphysics, this philosophy was not very effective. As usual, the broom of the anti-metaphysist sweeps away too much and also too little. As a result, we are left with an untidy and altogether untenable demarcation. For an illustration of too much and too little, I may perhaps cite the following passage from Carnap's Psychology within the Physical Language. Physics is, altogether, practically free from metaphysics, thanks to the efforts of Mach, Poincare, and Einstein. In psychology, efforts to make it a science free from metaphysics have hardly begun. Now, free from metaphysics means here, for Carnap, reducible to protocol statements. But not even the simplest physical statements about the functioning of a potentiometer, the example is Carnap's, are so reducible. Nor do I see any reason why we should not introduce mental states in our explanatory psychological theories, if in physics, old or new, we are permitted to explain the properties of a conductor by the hypotheses of an electric fluid or of an electronic gas. The point is that all physical theories say much more than we can test. Whether this more belongs legitimately to physics, or whether it should be eliminated from the theory as a metaphysical element, is not always easy to say. Carnap's reference to Mach, Poincare, and Einstein was unfortunate, since Mach, more especially, looked forward to the final elimination of atomism, which he, with many other positivists, considered to be a metaphysical element of physics. He eliminated too much. Poincare tried to interpret physical theories as implicit definitions, a view which can hardly be more acceptable to Carnap. And Einstein has, for a long time, been a believer in metaphysics, operating freely with the concept of the physically real, although, no doubt, he dislikes pretentious metaphysical verbiage as much as any of us. Most of the concepts with which physics works, such as forces, fields, and even electrons and other particles, are what Berkeley, for example, called qualitatis occultae. Carnap showed that assuming conscious states in our psychological explanations was exactly analogous to assuming a force, a qualitas occulta, in order to explain the strength of a wooden post. And he believed that such a view commits the fallacy of hypostasiation, of which he suggested no physicist is guilty, although it is often committed by the psychologists. But the fact is that we cannot explain the strength of the post by its structure alone, as Carnap suggested, but only by its structure together with laws which make ample use of hidden forces, which Carnap, like Berkeley, condemned as occult. Before concluding point A, I wish to mention only briefly that this physicalism, although from my point of view too physicalistic in most respects, was not physicalistic enough in others. For I do believe, indeed, that whenever we wish to put a scientific statement to an observational test, this test must in a sense be physicalistic. That is to say, that we test our most abstract theories, psychological as well as physical, by deriving from them statements about the behavior of physical bodies. I have called simple descriptive statements, describing easily observable states of physical bodies, basic statements, and I asserted that in cases in which tests are needed, it is these basic statements which we try to compare with the facts, and that we choose these statements and these facts because they are most easily comparable and intersubjectively most easily testable. Thus, according to my view, we do not, for the purpose of such basic tests, choose reports which are difficult to test intersubjectively about our own observable experiences, but rather reports which are easy to check about physical bodies, including potentiometers, which we have observed. The point is important because this theory of mine concerning the physicalistic character of test statements is radically opposed to all those widely accepted theories which hold that we are constructing the external world of science out of our own experiences. I've always believed that this is a prejudice. It is still widely held, and that, quite properly, we never trust our own experiences, unless we are confident that they conform with intersubjectively testable views. Now, on this point, Carnap's and Neurath's views were much less physicalistic at that time. In fact, they still upheld a form of Carnap's original methodological solipsism, for they taught that the sentences which formed the empirical basis, in my terminology, of all tests, and which they called protocol sentences, should be reports about our own observational experiences, although expressed in a physical language, that is, as reports about our own bodies. In Otto Neurath's formulation, such a protocol sentence was to have, accordingly, a very queer form. He wrote, "A complete protocol sentence might, for example, read, Otto's protocol at 3:17, Otto's verbalized thinking was at 3:16, in his room at 3:15 was a table, observed by Otto." One sees that the attempt is made here to incorporate the old starting point, the observer's own subjective experiences, that is, methodological solipsism. Carnap later accepted my view, but in the article on the protocol sentences, in which he very kindly called this view of mine the most adequate of the forms of scientific language at present advocated in the theory of knowledge, he did not yet quite appreciate the fact, appreciated clearly in Testability and Meaning, as we shall see, that the difference between my view and Neurath's concerned a fundamental point, whether or not to appeal in our tests to simple, observable, physical facts or to our own sense experiences, methodological solipsism. He therefore said, in his otherwise admirable report of my views, that the testing subject S will, in practice, often stop his tests when he has arrived at the observational statements of the protocoling subject S, that is, at statements of his own sense experience, whereas I held that he would stop only when he had arrived at a statement about some easily and intersubjectively observable behavior of a physical body, which at the moment did not appear to be problematic. The point here mentioned is, of course, closely connected with the fact that I never believed in induction, for which it seems natural to start from our own experiences, but in a method of testing predictions deducible from our theories, while Neurath believed in induction. At that time, I thought that, when reporting my views, Carnap had given up his belief in induction. If so, he has returned to it since. B. The language of unified science. Closely connected with physicalism was the view that the physicalistic language was a universal language in which everything meaningful could be said. The physical language is universal, Carnap wrote. If, because of its character, as a universal language, we adopt the language of physics as a language of science, then all science turns into physics. Metaphysics is excluded as nonsensical. The various sciences become parts of the unified science. It is clear that this thesis of the one universal language of the one unified science is closely connected with that of the elimination of metaphysics. If it were possible to express everything that a non-metaphysical scientist may wish to say in one language, which, by its rules, makes it impossible to express metaphysical ideas, then something like a prima facie case would have been made out in favor of the conjecture that metaphysics cannot be expressed in any reasonable language. Of course, the conjecture would be still very far from being established. Now, the queer thing about this thesis of the one universal language is that before it was ever published, on the 30th of December 1932, it had been refuted by one of Carnap's colleagues in the Vienna Circle. For Gödel, by his two famous incompleteness theorems, had proved that one unified language would not be sufficiently universal for even the purposes of elementary number theory, although we may construct a language in which all assertions of this theory can be expressed. No such language suffices for formalizing all the proofs of those assertions which, in some other language, can be proved. It would have been best, therefore, to scrap forthwith this doctrine of the one universal language of the one universal science, especially in view of Gödel's second theorem, which showed that it was pointless to try to discuss the consistency of a language in that language itself. But more has happened since to establish the impossibility of the theses of the universal language. I have in mind, especially, Tarski's proof that every universalistic language is paradoxal, first published in 1933 in Polish and in 1935 in German. But in spite of all this, the doctrine has survived. At least, I have nowhere seen a recantation. And the so-called International Encyclopedia of Unified Science, which was founded upon his doctrine, despite my opposition at the First Congress of Scientific Philosophy in Paris in 1935, is still being continued. It will remain a monument to a metaphysical doctrine, once passionately held by Narrated and brilliantly wielded by him as a major weapon in the anti-metaphysical crusade. For, no doubt, the strong philosophical belief which inspired this forceful and lovable person was, by his own standards, purely metaphysical. A unified science in a unified language is really nonsense, I'm sorry to say, and demonstrably so, since it has been proved by Tarski that no consistent language of this kind can exist. Its logic is outside it. Why should not its metaphysics be outside it too? I do not, of course, suggest that Carnap did not know all this, but I suggest that he did not see its devastating effect upon the doctrine of the unified science in the unified language. It may be objected, perhaps, that I am taking the doctrine of the unified language too seriously, and that a strictly formalized science was not intended. Narrated, for example, used to speak, especially in his later publications, of a universal slang, which indicates that he did not think of a formalized universal language. I believe that this is true, but this view, again, destroys the doctrine of the meaninglessness of metaphysics. For if there are no strict rules of formation for the universal slang, then the assertion that we cannot express metaphysical statements in it is gratuitous, and it can only lead us back to the naive, naturalistic view of meaninglessness, criticized above in section 3. It may be mentioned in this context that Gödel's and Church's discoveries also sealed the fate of another of the pet doctrines of positivism, and of one of my pet aversions. I have in mind Wittgenstein's "the riddle does not exist. If a question can be put at all, it can also be answered." This doctrine of Wittgenstein's, called by Carnap in the Aufbau the proud theses of the omnipotence of rational science, was hardly tenable even when it first appeared, if we remember Brouwer's ideas, published long before the Tractatus was written. With Gödel, especially with his second theorem of undecidability, and Church, its situation became even worse, for from them we learnt that we could never complete even our methods of solving problems. Thus, a well-formed mathematical question may become meaningless if we adopt a criterion of meaning according to which the meaning of a statement lies in the method by which it can be verified, in mathematics proved or disproved. This shows that we may be able to formulate a question, and similarly the possible answers to it, without an inkling as to how we might find out which of the possible answers is true, which demonstrates the superficiality of Wittgenstein's proud theses. Carnap was the first philosopher who recognized the immense importance of Gödel's discoveries, and he did his best to make them known to the philosophical world. It is the more surprising that Gödel's result did not produce that change which should have been produced in the Vienna Circle's tenets. In my opinion, undoubtedly and obviously metaphysical tenets, all too tenaciously held, concerning the language and the scope of science. C. Carnap's logical syntax is one of the few philosophical books which can be described as of really first-rate importance. Admittedly, some of its arguments and doctrines are superseded, owing mainly to Tarski's discoveries, as Carnap himself explained frankly in that famous last paragraph of his Introduction to Semantics. Admittedly, the book is not easy to read, and even more difficult in English than in German. But it is my firm conviction that, if ever a history of the rational philosophy of the earlier half of this century should be written, this book ought to have a place in it, second to none. I cannot even try here, wedged between critical analysis, to do justice to it. But one point at least I must mention. It was through this book that the philosophical world, to the west of Poland, was first introduced to the method of analyzing languages in a meta-language and of constructing object languages, a method whose significance for logic and the foundations of mathematics cannot be overrated. And it was in this book that the claim was first made and, I believe, completely substantiated that this method was of the greatest importance for the philosophy of science. If I may speak personally, the book, which came out a few months before my Logic of Scientific Discovery, and which I read while my book was in the press, marks the beginning of a revolution in my own philosophical thinking, although I did not understand it fully because of its real internal difficulties, I believe. Before I had read Tarski's great paper on the concept of truth, in the German translation 1935. Then I realized, of course, that a syntactic meta-linguistic analysis was inadequate and must be replaced by what Tarski called semantics. Of course, I believe that from the point of view of the problem of demarcation, a great step forward was made in the syntax. I say of course, since I am alluding to the fact that some of my criticism was accepted in this book. Part of the relevant passage is quoted above in note 24. But what is most interesting from our present point of view is the passage immediately following the quotation. It shows, I believe, that Carnap did not accept enough of my criticism. The view he presented, he writes, allows great freedom in the introduction of new primitive concepts and new primitive sentences in the language of physics or of science in general. Yet at the same time, it retains the possibility of differentiating pseudo-concepts and pseudo-sentences from real scientific concepts and sentences, and thus of eliminating the former. Here we find again the old theses of the meaninglessness of metaphysics, but it is mitigated, if only a little, by the immediate continuation of this passage, which Carnap places in square brackets, and which shows the influence of my criticism, mentioned by him on the preceding page. This elimination, however, is not so simple as it appeared on the basis of the earlier position of the Vienna Circle, which was in essentials that of Wittgenstein. On that view, it was a question of the language in an absolute sense. It was thought possible to reject both concepts and sentences if they did not fit into the language. The position indicated by these passages, including the one quoted briefly in note 24 above, may be described as follows. 1. Some difficulties, especially those of Wittgenstein's verifiability criterion of meaning, are recognized. Also, the inadequacy of what I have called the naturalistic theory of meaningfulness, which corresponds to the belief in the language, in which things simply are, or are not, essentially meaningful by their nature. 2. But the belief is still maintained that we can, by some feat of ingenuity, establish one language which does the trick of rendering meaningless precisely the metaphysical concepts and sentences and no others. 3. Even the belief that we can construct one universal language of unified science is still upheld, in consequence of 2. But it is not stressed and not examined in detail. See point B in this section above, and especially the passage from the syntax, section 74, page 286, mentioned in note 43 above. This situation does not call for further criticism on my part. Practically all that needs to be said, I have said already, especially that this approach renders tasky semantics meaningless, and with it, most of the theory of logical inference, that is, of logic. Only one further, and I believe important, comment has to be made. One of the difficulties of this great and important book of Carnap's lies in its emphasis upon the fact that the syntax of a language can be formulated in that language itself. The difficulty is the greater because the reader has hardly learnt to distinguish between an object language and a meta-language when he is told that, after all, the distinction is not quite as radical as he supposed it to be, since the meta-language, it is now emphasized, may form part of the object language. Carnap's emphasis is undoubtedly misplaced. It is a fact that part of the meta-language, namely its syntax, can form part of the object language. But although this fact is very important, as we know from Gödel's work, its main use is in the construction of self-referring sentences, which is a highly specialized problem. From the point of view of promoting the understanding of the relation between object language and meta-language, it would no doubt have been wiser to treat the meta-language as distinct from the object language. It could, of course, have still been shown that at least part of the meta-language, and enough for Gödel's purposes, may be expressed in the object language, without stressing the mistaken theses that the whole of the meta-language can be so expressed. Now, there is little doubt that it was the doctrine of the one universal language in which the one unified science was to be expressed that led Carnap to this emphasis, which contributes so much to the difficulties of his book. For he hoped to construct a unified language which would automatically eliminate metaphysics. It is a great pity to find this excellent book spoiled by an anti-metaphysical dogma and by wrong demarcation which eliminates, together with metaphysics, the most important parts of logic. The syntax continues the doctrine of the meaninglessness of metaphysics in the following form. All meaningful sentences either belong to the language of science, or, if philosophical, they can be expressed within the syntax of that language. This syntax comprises the whole of the philosophy and logic of science, so far as these are translatable into the formal mode of speech. Moreover, this syntax can, if we wish, be formulated in the same universal object language in which all the sciences may be formulated. Here, it is not only the doctrine of the one universal language which I cannot accept. I also cannot accept the ruling that what I say must be translatable into the formal mode of speech in order to be meaningful, or to be understood by Carnap. No doubt one should express oneself as clearly as possible, and no doubt what Carnap calls the formal mode of speech is often preferable to what he calls the material mode, and I have often used it in my Logic of Scientific Discovery and before, without having been told to do so. But it is not necessarily preferable. And why should it necessarily be preferable? Perhaps because the essence of philosophy is language analysis? But I am not a believer in essences, nor in Wittgenstein. How to make oneself better understood can only be a matter of thought and experience. And why should all philosophy be linguistic analysis? No doubt it may often help to put a question in terms of language construction, but why should all philosophical questions be of this kind? Or is this the one and only non-linguistic thesis of philosophy? The positivistic attack has put, if I may say so, the fear of God into all of us who wish to speak sense. We have become more careful in what we say and how we say it, and this is all to the good. But let us be clear that the philosophical thesis that language analysis is everything in philosophy is paradoxal. I admit that this criticism of mine no longer applies in this form to testability and meaning, which replaces the thesis by a proposal that is no longer paradoxal. No reasons, however, are offered in favour of the proposal, except that it is an improved version of the theses, and this is no reason, it seems to me, for accepting it. 5. Testability and meaning. Carnap's Testability and Meaning is perhaps the most interesting and important of all the papers in the field of the philosophy of the empirical sciences, which were written in the period between Wittgenstein's Tractatus and the German publication of Tarski's essay on the concept of truth. It was written in a period of crisis and marks great changes in the author's views. At the same time, its claims are very modest. The object of this essay is not to offer solutions. It aims rather to stimulate further investigations. This aim was amply realized. The investigations which sprang from it must number hundreds. Replacing verifiability by testability, or by confirmability, testability and meaning is, as its title indicates, very largely a treatise on our central problem. It still attempts to exclude metaphysics from the language of science. An attempt will be made to formulate the principle of empiricism in a more exact way by stating a requirement of confirmability or testability as a criterion of meaning. We read in section 1. And in section 27, page 33, this hint is elaborated. As empiricists, we require the language of science to be restricted in a certain way. We require that descriptive predicates and hence synthetic sentences are not to be admitted unless they have some connection with possible observations. What is not to be admitted is, of course, metaphysics. Even if L were to be a language adequate for all science, we should not wish, for example, to have, in L, sentences corresponding to many or perhaps most of the sentences occurring in the books of metaphysicians. Thus, the main idea, excluding metaphysics from well-formed formulae of L, the language of science, is unchanged. Unchanged, too, is the idea of the one language of science, although Carnap now says, very clearly, that we can choose our language, and that various scientists can choose it in different ways. He proposes that we accept a universal language, and he even defends the theses of physicalism in a modified form. He often speaks, as in the passages quoted, of the language of science, of the possibility of having a language for all science, or of the whole or the total language of science. The impossibility of such a language he still does not realize. Carnap is, however, very careful in the formulation of his new ideas. He says that we have a choice between many languages of science, and he says that the principle of empiricism, which turns out to be another name for the principle of the meaninglessness of metaphysics, should preferably be formulated not as an assertion, but as a proposal or requirement for selecting a language of science. One might think that, with this formulation, the idea of excluding metaphysics as meaningless has in fact been abandoned, for the metaphysician need not, and clearly would not, accept any such proposal. He would simply make another proposal in its place, according to which metaphysics would become meaningful, in an appropriate language. But this is not how Carnap sees the situation. He sees it, rather, as the task or the duty imposed upon the anti-metaphysician to justify his view of the meaninglessness of metaphysics by constructing a language of science free from metaphysics. And this is how the problem is still seen by many, I fear. It is easy to show, using my old arguments, that no such language can be constructed. My thesis is that a satisfactory language for science would have to contain, with any well-formed formula, its negation, and since it has to contain universal sentences, it has therefore to contain existential sentences also. But this means that it must contain sentences which Carnap, Narrated, and all other anti-metaphysicians always considered to be metaphysical. In order to make this quite clear, I choose, as an extreme example, what might be called the arch-metaphysical assertion. There exists an omnipotent, omnipresent, and omniscient personal spirit. I shall briefly show how this sentence can be constructed as a well-formed or meaningful sentence in a physicalistic language, which is quite similar to the proposed in Testability and Meaning. We can take as primitive the following four physicalistic predicates. 1. The thing A occupies a position B, or more precisely, A occupies a position of which the point or region B is a part. In symbols POS in brackets A, B. 2. The thing, machine or body or person, A, can put the thing B into position C. In symbols PUT in brackets A, B, C. 3. A makes the utterance B. In symbols UTT in brackets A, B. 4. A is asked, that is, adequately stimulated by an utterance combined, say, with a truth drug, whether or not B. In symbols ASK in brackets A, B. We assume that in our language we have at our disposal names of all the expressions of the form POS in brackets A, B, PUT in brackets A, B, C, etc., including some of those introduced below with their help. I shall use for simplicity's sake quotation names. I am aware, however, of the fact that this procedure is not exact, especially where variables in quotes abound, as in 14, but this difficulty can be overcome. Now, we can easily introduce, with the help of explicit definitions using 1 and 2, 5. A is omnipresent, or OPOS in brackets A. 6. A is omnipotent, or OPUT in brackets A. Moreover, with the help of 3 and 4, we can introduce, by Carnap's reduction method, 7. A thinks B, or TH in brackets A, B. Carnap recommends that such a predicate should be admitted. With the help of 7, we can now define explicitly 8. A is a thinking person, or THP in brackets A. 9. A is a personal spirit, or SP in brackets A. 10. A knows that B is in position C, or KNPOS in brackets A, B, C. 11. A knows that B can put C into the position D, or KNPUT in brackets A, B, C, D. 12. A knows that B thinks C, or KNTH in brackets A, B, C. 13. A is unfathomable, or UNKN in brackets A. 14. A knows the fact B, or KN in brackets A, B. 15. A is truthful, or verax in comma A. 16. A is omniscient, or OKN in brackets A. Nothing is now easier than to give an existential formula expressing the arch-metaphysical assertion that a thinking person A exists, positioned everywhere, able to put anything anywhere, thinking all and only what is in fact true, and with nobody else knowing all about A's thinking. The uniqueness of an A of this kind is demonstrable from A's properties. We cannot, however, identify A with the God of Christianity. There is a difficulty in defining morally good on a physicalistic basis. But questions of definability are, anyway, in my opinion, supremely uninteresting outside mathematics, except to essentialists. See below. It is clear that our purely existential arch-metaphysical formula cannot be submitted to any scientific test. There is no hope whatever of falsifying it, or finding out, if it is false, that it is false. For this reason, I describe it as metaphysical, as falling outside the province of science. But I do not think Carnap is entitled to say that it falls outside science, or outside the language of science, or that it is meaningless. Its meaning seems to me perfectly clear. It is also clear that some logical analysts must have mistaken its empirical incredibility for meaninglessness. But one could even conceive of experiments which might confirm it, in Carnap's sense, that is to say, weakly verify it. See text to note 67. It helps us very little if we are told, in Testability, that the meaning of a sentence is, in a certain sense, identical with the way we determine its truth and falsehood, and a sentence has meaning only if such a determination is possible. One thing emerges clearly from this passage, that it is not Carnap's intention to allow meaning to a formula like the arch-metaphysical one, but the intention is not realized. It is not realized, I think, because it is not realizable. I need hardly say that my only interest in constructing our arch-metaphysical existential formula is to show that there is no connection between well-formedness and scientific character. The problem of how to construct a language of science, which includes all we wish to say in science, but excludes those sentences which have always been considered as metaphysical, is a hopeless one. It is a typical pseudo-problem, and nobody has ever explained why it should be so interesting to solve it, if it is soluble. Perhaps in order to be able to say, as before, that metaphysics is meaningless, but this would not mean anything like what it meant before. But it may be said, it may still be possible to realize at least part of the old Wittgensteinian dream and to make metaphysics meaningless. For perhaps Carnap was simply too generous in allowing us to use dispositional predicates, such as A is able to put B into C and A thinks B, the latter characterized as a disposition to utter B. I cannot hold out any hope to those who pursue this line of thought. As I tried to show when discussing the Aufbau in section 3, we need in science genuine non-existential universals. But in my logic of scientific discovery, I indicated briefly, much too briefly, for I thought that the reductionist ideas of the Aufbau had been given up by its author, that all universals are dispositional, not only a predicate like soluble, but also dissolving or dissolved. If I may quote from my logic of scientific discovery, every descriptive statement uses universals. Every statement has the character of a theory, of a hypothesis. The statement, "Here is a glass of water," cannot be verified by any observational experience. The reason is that the universals which occur in it cannot be correlated with any particular observational experience. By the word glass, for example, we denote physical bodies which exhibit a certain law-like behavior, and the same applies to the word water. Universals cannot be constituted, that is, they cannot be defined in the manner of the Aufbau. What then is the answer to the problem of defining or introducing a dispositional term like soluble? The answer is simply that the problem is insoluble, and there is no need whatever to regret this fact. It is insoluble, for assume we have succeeded in reducing X is soluble in water by what Carnap calls a reduction sentence, describing an operational test, such as if X is put into water, then X is soluble in water if and only if it dissolves. What have we gained? We have still to reduce water and dissolves, and it is clear that among the operational tests which characterize water, we should have to include if anything that is soluble in water is put into X, then if X is water, that thing dissolves. In other words, not only are we forced, in introducing soluble, to fall back upon water, which is dispositional in perhaps even a higher degree, but in addition, we are forced into circularity, for we introduce soluble with the help of a term water, which, in its turn, cannot be operationally introduced without soluble, and so on, ad infinitum. The situation with X is dissolving, or X has dissolved, is very similar. We say that X has dissolved, rather than that it has disappeared, only if we expect to be able to show, say by evaporating the water, that certain traces of this process can be found, and that we can, if necessary, even identify parts of the dissolved and later reclaimed substance with parts of X by tests which will have to establish, among other things, the fact that the reclaimed substance is, again, soluble. There is a very good reason why this circle cannot be broken by establishing a definite order of reduction or introduction. It is this: our actual tests are never conclusive and always tentative. We never should agree to a ruling telling us to stop our tests at any particular point, say when arriving at primitive predicates. All predicates are, for the scientist, equally dispositional, that is, open to doubt and to tests. This is one of the main ideas of the theory of the empirical basis in my logic of scientific discovery. So much about the fact that soluble cannot be reduced to something that is less dispositional. As to my contention that there is no need to regret this fact, I want only to say again that outside mathematics and logic, problems of definability are mostly gratuitous. We need many undefined terms, whose meaning is only precariously fixed by usage, by the manner in which they are used in the context of theories, and by the procedures and practices of the laboratory. Thus, the meaning of these concepts will be changeable, but this is so with all concepts, including defined ones, since a definition can only reduce the meaning of the defined term to that of undefined terms. What, then, is behind the demand for definitions? An old tradition, reaching back far beyond Locke to Aristotelian essentialism, and, as a result of it, a belief that if a man was unable to explain what a word meant which he used, then this showed that he had given no meaning to it, Wittgenstein, and had therefore been talking nonsense. But this Wittgensteinian belief is nonsense, since all definitions must ultimately go back to undefined terms. However, since I have discussed all this elsewhere, I shall say nothing further about it here. In concluding this section, I wish to stress again the point that testability and confirmability, even if satisfactorily analysed, are in no way better fitted to serve as criteria of meaning than the older criterion of verifiability. But I must say that, in addition, I am unable to accept Carnap's analysis of either test, testable, etc., or of confirmation. The reason is, again, that his terms are substitutes for verification, verifiable, etc., slightly weakened so as to escape the objection that laws are not verifiable. But this compromise is inadequate, as we shall see in the next and last section of this paper. Acceptability in science depends not upon anything like a truth surrogate, but upon the severity of tests. 6. Probability and induction. The full consequences of approaching confirmation as if it was a kind of weakened verification became manifest only in Carnap's 2 books on probability. The big volume entitled Logical Foundations of Probability, referred to here as Probability, and the smaller progress report, The Continuum of Inductive Methods, referred to here as Methods. The topics of these 2 books are very closely related to our problem. They deal with the theory of induction, and the method of induction has always been one of the most popular criteria of demarcation for science. For the empirical sciences are, as a rule, considered to be characterized by their methods, and these, in turn, are usually characterized as inductive. This is Carnap's view too. His new criterion of demarcation is, as we have seen, confirmability. And in these 2 books, Carnap explains that the methods of confirming a sentence are identical with the inductive method. Thus, we must conclude that the criterion of demarcation now becomes, more precisely, confirmability by inductive methods. In other words, a linguistic expression will belong to the empirical sciences if, and only if, it is logically possible to confirm it by inductive methods, or by inductive evidence. As I have indicated in section 2, this criterion of demarcation does not satisfy my requirements. All sorts of pseudosciences, such as astrology, are clearly not excluded. The answer to this would be, no doubt, that the criterion is not intended to exclude what I call pseudosciences, and that these consist simply of false sentences, or perhaps of disconfirmed sentences, rather than of metaphysical, non-confirmable ones. I am not satisfied by this answer, believing as I do that I have a criterion which excludes, for example, astrology, and which has proved extremely fruitful in connection with a host of problems. But I am prepared to accept it for argument's sake, and to confine myself to showing, as before, that the criterion produces the wrong demarcation. My criticism of the verifiability criterion has always been this. Against the intention of its defenders, it did not exclude obvious metaphysical statements, but it did exclude the most important and interesting of all scientific statements, that is to say, the scientific theories, the universal laws of nature. Now, let us see how these 2 groups of statements fare under the new criterion. As to the first, it turns out that my arc metaphysical existential formula obtains, in Carnap's system, a high confirmation value, for it belongs to the almost tautological, almost true, sentences whose confirmation value is 1, or, in a finite world of sufficient size, indistinguishable from 1. Moreover, it is a kind of statement for which even experimental confirmation is conceivable, although no tests in my sense, there is no conceivable way of refuting it. Its lack of refutability puts it into the class of metaphysical sentences by my criterion of demarcation. Its high confirmation value in Carnap's sense, on the other hand, should make it vastly superior to, and more scientific than, any scientific law. For all universal laws have 0 confirmation, according to Carnap's theory, in a world which is in a sense infinite, temporal infinity suffices, as Carnap himself has shown, and even in a finite world, their value would be indistinguishable from zero if the number of events or things in this world is sufficiently large. All this is an obvious consequence of the fact that confirmability and confirmation, in Carnap's sense, are just slightly weakened versions of verifiability and verification. The reason why the universal laws are not verifiable is thus identical with the reason why they are not confirmable. They assert a great deal about the world, more than we can ever hope either to verify or to confirm. In face of the fact that natural laws turn out to be non-confirmable, according to his definition of degree of confirmation, Carnap adopts two courses. A. He introduces ad hoc a new concept called the qualified instance confirmation of the law 1, which is so defined that we sometimes obtain, in place of 0, a confirmation value close to 1. B. He explains that natural laws are not really needed in science and that we can dispense with them. Verificationism made them meaningless. Confirmationism merely makes them unnecessary. This is the gain which the weakening of the verifiability criterion achieves. I shall now discuss A and B a little more fully. A. Carnap realizes, of course, that his zero confirmation of all laws is counterintuitive. He therefore suggests measuring the intuitive reliability of a law by the degree of confirmation of an instance of the law. But he nowhere mentions that this new measure, introduced on page 572 of probability, satisfies practically none of the criteria of adequacy and none of the theorems which have been built up on the preceding 571 pages. This is so, however, and the reason is that the instance confirmation of a law 1 on the evidence E is simply not a probability function of 1 and E, not a regular C function of 1 and E. And it could hardly be otherwise. We are given, up to page 570, a detailed theory of confirmation in the sense of probability. On page 571, we find that, for a law, this confirmation is 0. We are now faced with the following alternatives. Either 1. We accept the result as correct, and consequently say that the degree of rational belief in a well-supported law cannot differ appreciably from 0, or from that of a refuted law, or even from a self-contradictory sentence. Or 2. We take the result as a refutation of the claim that our theory has supplied us with an adequate definition of degree of confirmation. The ad hoc introduction of a new measure, in order to escape from an unintended result, is hardly an acceptable third possibility. But what is most unsatisfactory is to take this momentous step, a break with the method of explication used so far, without giving any warning to the reader. This may result in the serious misconception that only a minor adjustment has been made. For if we are to take probability or confirmation at all seriously, then the adjustment could not have been more radical. It replaces a confirmation function whose value is 0 by another whose value will be often close to 1. If we permit ourselves the freedom thus to introduce a new measure with no better justification than that the 0 probability was counterintuitive, while the probability near to 1 seems to represent still more accurately what is vaguely meant by the reliability of a law, then we can obtain for any sentence any probability or degree of confirmation we like. Moreover, Carnap nowhere attempts to show that the newly introduced instance confirmation is adequate, or at least consistent, which it is not. See note 68 above. No attempt is made, for example, to show that every refuted law obtains a lower instance confirmation than any of those which have stood up to tests. That this minimum requirement cannot be satisfied, even after repairing the inconsistency, may be shown with the help of Carnap's example, the law, all swans are white. This law ought to be considered as falsified if our evidence consists of a flock of one black and, say, 1,000 white swans. But upon this evidence, the instance confirmation, instead of being 0, will be very near to 1. The precise difference from 1 will depend upon the choice of the parameter, discussed below. More generally, if a theory is again and again falsified, on the average, in every numbered instance, then its qualified instance confirmation approaches 1 minus 1 over n instead of 0, as it ought to do, so that the law, all tossed pennies always show heads, has the instance confirmation half instead of 0. In discussing in my Logic of Scientific Discovery a theory of Reichenbach's which leads to mathematically equivalent results, I described this unintended consequence of his theory as devastating. After 20 years, I still think it is. B. With his doctrine that laws may be dispensed with in science, Carnap in effect returns to a position very similar to the one he had held in the heyday of verificationism, namely that the language of science is molecular, and which he had given up in the syntax and in testability. Wittgenstein and Schlick, finding that natural laws are non-verifiable, concluded from this that they are not genuine sentences, overlooking that they were thus committed to calling them meaningless pseudo-sentences. Not unlike Mill, they described them as rules for the derivation of genuine singular sentences, the instances of the law, from other genuine sentences, the initial conditions. I criticized this doctrine in my Logic of Scientific Discovery, and when Carnap accepted my criticism in the syntax and in testability, I thought that the doctrine was dead. But with Carnap's return to verificationism in a weakened form, it has come to life again. In a weakened form, I do not think that the odds for its survival are good. In one respect, Carnap goes even further than Schlick. Schlick believed that without laws we could not make predictions. Carnap, however, asserts that the use of laws is not indispensable for making predictions. And he continues, nevertheless, it is expedient, of course, to state universal laws in books on physics, biology, psychology, etc., although these laws stated by scientists do not have a high degree of confirmation, he writes. But this is an understatement, since their degree of confirmation could not be lower. They have a high qualified instance confirmation. While reading through this section of my paper, Dr. J. Agassi has found a simple, and I believe new, paradox of inductive confirmation, which he has permitted me to report here. It makes use of what I propose to call an Agassi predicate, a factual predicate, A in brackets X, which is so chosen as to hold for all individuals, events or perhaps things, occurring in the evidence at our disposal, but not for the majority of the others. For example, we may choose, at present, to define A in brackets X as X has occurred or has been observed before 1st of January 1965. Another choice, Berkeley's choice, as it were, would be X has been perceived. Then it follows from Carnap's theory that, with growing evidence, the degree of confirmation of A in brackets A must become indistinguishable from 1 for any individual A in the world, present, past, or future. And the same holds for the qualified or unqualified instance confirmation of the universal law. XAX, a law stating that all events in the world, present, past, or future, occur before 1965, which makes 1965 an upper bound for the duration of the world. Clearly, the famous cosmological problem of the approximate period of the creation can be equally easily dealt with. Nevertheless, it would hardly be expedient to state universal laws like those of Agassiz in books on cosmology, in spite of their high instance confirmation. In the last pages of Testability, Carnap discussed the sentence, "If all minds should disappear from the universe, the stars would still go on in their courses." Lewis and Schlick asserted, correctly, that this sentence was not verifiable, and Carnap replied, equally correctly, in my opinion, that it was a perfectly legitimate scientific assertion, based as it was on well-confirmed universal laws. But by now, universal laws have become dispensable, and without them, the sentence in question cannot possibly be upheld. Moreover, one sees easily from Agassiz's argument that a sentence that contradicts it can be maximally confirmed. But I do not intend to use this one case, the status of natural laws, as my main argument in support of my contention that Carnap's analysis of confirmation, and with it his criterion of demarcation, are inadequate. I therefore now proceed to offer, in support of this contention, arguments which are completely independent of the case of natural laws, although they may allow us to see more clearly why this inadequacy was bound to arise in Carnap's theory. As motto for my criticism, I take the following challenging passage of Carnap's. If it could be shown that another method, for instance a new definition for degree of confirmation, leads in certain cases to numerical values more adequate than those furnished by C, that would constitute an important criticism. Or, if someone were to show that any adequate explicatum must fulfill a certain requirement and that C does not fulfill it, it might be a helpful first step towards a better solution. I shall take up both alternatives of this challenge, but reverse their order. 1. I shall show that an adequate concept of confirmation cannot satisfy the traditional rules of the calculus of probability. 2. I shall give an alternative definition of degree of confirmation. Ultimately, I shall show 3. That Carnap's theory of confirmation appears to involve A. an infinite regress, and B. an a priori theory of the mutual dependence of all atomic sentences with like predicates. 1. To begin with, I suggest that we distinguish not only between logical probability, probability 1, and relative frequency, probability 2, as Carnap does, but between at least 3 different concepts, the third being degree of confirmation. Surely, as a first suggestion, this is unobjectionable. We could still decide, after due investigation, that logical probability can be used as the explicandum for degree of confirmation. Carnap unfortunately prejudges the issue. He assumes, without any further discussion, that his distinction between 2 probability concepts is sufficient, neglecting the warnings of my old book. It can be shown that confirmation, as Carnap himself understands this concept, cannot be logical probability. I offer 3 arguments. A. We can easily agree on the kind of thing we may both call, provisionally, probability, for we both call probability something that satisfies the laws of the calculus of probability. More specifically, Carnap says of the concept of logical probability 1 that it satisfies certain axiom systems, and in any case the special addition principle and general multiplication principle. Now, it is an elementary consequence of the latter that the more a statement asserts, the less probable it is. This may be expressed by saying that the logical probability of a sentence X on a given evidence Y decreases when the informative content of X increases. But this is sufficient to show that a high probability cannot be one of the aims of science, for the scientist is most interested in theories with a high content. He does not care for highly probable trivialities, but for bold and severely testable and severely tested hypotheses. If, as Carnap tells us, a high degree of confirmation is one of the things we aim at in science, then degree of confirmation cannot be identified with probability. This may sound paradoxical to some people, but if high probability were an aim of science, then scientists should say as little as possible, and preferably utter tautologies only. But their aim is to advance science, that is, to add to its content. Yet this means lowering its probability. And in view of the high content of universal laws, it is neither surprising to find that their probability is zero, nor that those philosophers who believe that science must aim at high probabilities cannot do justice to facts such as these. That the formulation and testing of universal laws is considered their most important aim by most scientists, or that the intersubjective testability of science depends upon these laws, as I pointed out in Section 8 of my Logic of Scientific Discovery. From what has been said, it should be clear that an adequately defined degree of confirmation cannot satisfy the general multiplication principle for probabilities. To sum up point A, since we aim in science at a high content, we do not aim at a high probability. B. The severity of possible tests of a statement or a theory depends, among other factors, on the precision of its assertions and upon its predictive power. In other words, upon its informative content, which increases with these two factors. This may be expressed by saying that the degree of testability of a statement increases with its content. But the better a statement can be tested, the better it can be confirmed, that is, attested by its tests. Thus, we find that the opportunities of confirming a statement, and accordingly the degree of its confirmability or corroborability or attestability, increase with its testability and with its content. To sum up point B, since we want a high degree of confirmation or corroboration, we need a high content and thus a low absolute probability. C. Those who identify confirmation with probability must believe that a high degree of probability is desirable. They implicitly accept the rule, always choose the most probable hypotheses. Now, it can be easily shown that this rule is equivalent to the following rule. Always choose the hypotheses which goes as little beyond the evidence as possible. And this, in turn, can be shown to be equivalent not only to always accept the hypotheses with the lowest content within the limits of your task, for example, your task of predicting, but also to always choose the hypotheses which has the highest degree of ad hoc character within the limits of your task. This is an unintended consequence of the fact that a highly probable hypothesis is one which fits the known facts, going as little as possible beyond them. But it is well known that ad hoc hypotheses are disliked by scientists. They are, at best, stopgaps, not real aims. Scientists prefer a bold hypothesis because it can be more severely tested and independently tested. To sum up point C, aiming at high probability entails a counterintuitive rule favoring ad hoc hypotheses. These three arguments exemplify my own point of view, for I see in a confirming instance the result of a severe test, or of an attempted but unsuccessful refutation of the theory. Those, on the other hand, who do not look for severe tests, but rather for confirmation in the sense of the old idea of verification, or a weakened version of it, come to a different idea of confirmability. A sentence will be the better confirmable, the more nearly verifiable it is, or the more nearly deducible from observation sentences. It is clear in this case that universal laws are not, as in our analysis, highly confirmable, but that owing to their high content, their confirmability will be zero. 2. In taking up the challenge to construct a better definition of confirmation, I wish to say first that I do not believe that it is possible to give a completely satisfactory definition. My reason is that a theory which has been tested with great ingenuity and with the sincere attempt to refute it will have a higher degree of confirmation than one which has been tested with laxity. And I do not think that we can completely formalize what we mean by an ingenious and sincere test. Nor do I think that it is an important task to give an adequate definition of degree of confirmation. In my view, the importance, if any, of giving the best possible definition lies in the fact that such a definition shows clearly the inadequacy of all probability theories posing as theories of induction. I have given what I consider a reasonably adequate definition elsewhere. I may give here a slightly simpler definition, which satisfies the same desiderata or conditions of adequacy. Please view your screen now to see Popper's formula for his definition of degree of confirmation. Here, C in brackets xy means the degree of confirmation of x by y, while P in brackets xy and P in brackets x are relative and absolute probabilities, respectively. The definition can be relativized. Please view your screen now to see the second formula. Here, Z should be taken as the general background knowledge, the old evidence and old and new initial conditions, including, if we wish, accepted theories, while Y should be taken as representing those new observational results excluded from Z, which may be claimed to confirm the new explanatory hypotheses, X. My definition satisfies, among other conditions of adequacy, the condition that the confirmability of a statement, its highest possible degree of confirmation, equals its content, that is, the degree of its testability. Another important property of this concept is that it satisfies the condition that the severity of a test, measured by the improbability of the test instance, has an almost additive influence upon the resultant degree of confirmation of the theory. This shows that some at least of the intuitive demands are satisfied. My definition does not automatically exclude ad hoc hypotheses, but it can be shown to give most reasonable results if combined with a rule excluding ad hoc hypotheses. So much about my own present positive theory, which goes very considerably beyond my logic of scientific discovery. But I must return to my critical task. I believe that my positive theory strongly suggests that the fault lies with the verificationist and inductivist approach, which, in spite of the attention paid to my criticism, has never been completely abandoned by Carnap. But inductive logic is impossible. I shall try to show this, following my old logic of scientific discovery, as my last critical point. 3. I asserted, in my logic of scientific discovery, that an inductive logic must involve either A, an infinite regress, discovered by Hume, or B, the acceptance, with Kant, of some synthetic principle as valid a priori. I have a strong suspicion that Carnap's theory of induction can be criticized as involving both A and B. A. If we need, in order to justify induction as probable, a probable principle of induction, such as a principle of the uniformity of nature, then we also need a second such principle in order to justify the induction of the first. Carnap, in his section on the presuppositions of induction, introduces a principle of uniformity. He does not mention the objection of a regress, but a remark in his exposition seems to indicate that he has it in mind. The opponents, he writes, page 181, would perhaps say that the statement of the probability of uniformity must be taken as a factual statement. Our reply is, this statement is itself analytic. I was far from convinced by Carnap's arguments, but since he indicates that the whole problem of the justification and the presupposition of inductive method will be treated in a later volume, in more exact technical terms, it is perhaps better to suppress, at this stage, my inclination to offer a proof that no such principle of uniformity can be analytic, except in a Pickwickian sense of analytic, especially since my discussion of point B will perhaps indicate the lines on which a proof of this kind might proceed. B. Natural laws, or more generally, scientific theories, whether of a causal or a statistical character, are hypotheses about some dependence. They assert, roughly speaking, that certain events or statements describing them are in fact not independent of others, although so far as their purely logical relations go, they are independent. Let us take two possible facts which are, we first assume, completely unconnected. Say, Chunky is clever and Sandy is clever, described by the two statements X and Y. Then somebody may conjecture, perhaps mistakenly, that they are connected, that Chunky is a relation of Sandy's, and that the information or evidence Y increases the probability of X. If he is wrong, that is, if X and Y are independent, then we have 1. P in brackets XY is equal to P in brackets X, which is equivalent to 2. P in brackets XY equals P in brackets X, P in brackets Y. This is the usual definition of independence. If the conjecture that the events are connected or interdependent is correct, then we have 3. P in brackets XY is greater than P in brackets X. That is, the information Y raises the probability of X above its absolute or initial value, P in brackets X. I believe, as I think most empiricists do, that any such conjecture about the interdependence or correlation of events should be formulated as a separate hypothesis or as a natural law. Cleverness runs in families, to be submitted first to a process of careful formulation with the aim of making it as highly testable as possible, and after that to severe empirical tests. Carnap is of a different opinion. He proposes that we accept, as probable, a principle to the effect that the evidence Sandy is clever increases the probability of A is clever for any individual A, whether A is the name of a cat, a dog, an apple, a tennis ball, or a cathedral. This is a consequence of the definition of degree of confirmation which he proposes. According to this definition, any two sentences with the same predicate, clever or sick, and different subjects are interdependent or positively correlated, whatever the subjects may be, and wherever they may be situated in the world. This is the actual content of his principle of uniformity. I am far from certain whether he has realized these consequences of his theory, for he nowhere mentions them explicitly. But he introduces a universal parameter which he calls lambda, and lambda plus 1 turns out, on a simple mathematical calculation, to be the reciprocal of the logical correlation coefficient for any two sentences with the same predicate and different subjects. The assumption that lambda is infinite corresponds to the assumption of independence. According to Carnap, we are bound to choose a finite value of lambda when we wish to choose our definition of the probability 1 function. The choice of lambda, and with it of the degree of correlation between any two sentences with the same predicate, thus appears to be part of a decision or convention, the choice of a definition of probability. It looks, therefore, as if no statement about the world was involved in the choice of lambda. but it is a fact that our choice of lambda is equivalent to the most sweeping assertion of dependence that one can imagine. It is equivalent to the acceptance of as many natural laws as there are predicates, each asserting the same degree of dependence of any two events with like predicates in the world. And since such an assumption about the world is made in the form of a non-testable act, the introduction of a definition, there seems to me an element of a priorism involved. One might still say, perhaps, that there is no a priorism here, since the dependencies mentioned are a consequence of a definition, that of probability or degree of confirmation, which rests on a convention or a decision and is therefore analytic. But Carnap gives two reasons for his choice of his confirmation function, which do not seem to fit this view. The first of the two reasons I have in mind is that his confirmation function, as he remarks, is the only one, among those which suggest themselves, which is not entirely inadequate. Inadequate, that is, for explaining or explicating the undoubted fact that we can learn from experience. Now, this fact is empirical, and a theory whose adequacy is judged by its ability to explain or cohere with this fact does not quite look like being analytic. It is interesting to see that Carnap's argument in favour of his choice of lambda, which I am suspecting of a priorism, is the same as Kant's or Russell's or Jeffrey's. It is what Kant called a transcendental argument. How is knowledge possible? The appeal to the fact that we possess empirical knowledge, that is, that we can learn from experience. The second of the two reasons is Carnap's argument that the adoption of an appropriate lambda, one which is neither infinite, for an infinite lambda is equivalent to independence, nor zero, would be more successful in nearly all universes, except in the two extreme cases in which all individuals are independent or have like properties. All these reasons seem to me to suggest that the choice of lambda, that is, of a confirmation function, is to depend upon its success, or upon the probability of its success in the world. But then it would not be analytic, in spite of the fact that it is also a decision concerning the adoption of a definition. I think that it can be explained how this may be so. We can, if we like, define the word truth so that it comprises some of those statements which we usually call false. Similarly, we can define probable or confirmed so that absurd statements get a high probability. All this is purely conventional or verbal, as long as we do not take these definitions as adequate explications. But if we do, then the question is no longer conventional or analytic. For to say of a contingent or factual statement X that it is true, in an adequate sense of the word true, is to make a factual statement. And so it is with X is now highly probable. It is the same with X is strongly dependent upon Y, and X is independent of Y, the statements whose fate is decided upon when we choose lambda. The choice of lambda is therefore indeed equivalent to that of adopting a sweeping, though unformulated statement about the general interdependence or uniformity of the world. But this statement is adopted without any empirical evidence. Indeed, Carnap shows that without adopting it, we can never learn from empirical evidence, according to his theory of knowledge. Thus, empirical evidence does not and cannot count before the adoption of a finite lambda. This is why it has to be adopted a priori. The principle of empiricism, Carnap writes in another context, can be violated only by the assertion of a factual synthetic sentence without a sufficient empirical foundation, or by the theses of a priorism, when it contends that for knowledge, with respect to certain factual sentences, no empirical foundation is required. I believe that what we have observed here shows that there is a third way of violating the principle of empiricism. We have seen how it can be violated by constructing a theory of knowledge which cannot do without a principle of induction. A principle that tells us, in effect, that the world is, or very probably is, a place in which men can learn from experience, and that it will remain, or very probably remain, so in the future. I do not believe that a cosmological principle of this kind can be a principle of pure logic, but it is introduced in such a way that it cannot be based upon experience either. It therefore seems to me that it cannot be anything else but a principle of a priori metaphysics. Nothing but the synthetic, the factual character of lambda seems to be able to explain Carnap's suggestion that we may try out which value of lambda is most successful in a given world. But since empirical evidence does not count without the prior adoption of a finite lambda, there can be no clear procedure for testing the lambda chosen by the method of trial and error. My own feeling is that I prefer, in any case, to apply the method of trial and error to the universal laws, which are indispensable for intersubjective science, which are clearly and admittedly factual, and which we may succeed in making severely testable, with the aim of eliminating all those theories that can be discovered to be erroneous. I am glad to have been given an opportunity to get these matters off my mind, or off my chest, as physicalists might say. I do not doubt that, with another vacation in the trial and another climb up the semantisch Schnoop, Carnap and I could reach agreement on most of these points, for we both, I trust, belong to the fraternity of rationalists, the fraternity of those who are eager to argue and to learn from one another. But since the physical gap between us seems unbridgeable, I now send to him across the ocean, knowing that soon I shall be at the receiving end, these my best barbed arrows, with my best brotherly regards.